Alright, now when you divide 32-bit by 4, it gives you 8. So therefore we have 8 bits inside the 32 inside each part. With that, we can refer to each as octets. Remember, when we're talking about sizes, we have in polygon, we have hexagon, decagon, nonagon. So octagon is 8. So therefore, we can refer to each part in IP version 4 as octets. So now this, in this case, we have how many octets? 4 octets. So if this is an octet, this is also an octet, this one is also an octet, and this one is also an octet. In all, we have 4 octets. That is in bits. You know, a typical IP version 4 looks like this. In your command line, if you type ipconfig just like this, you will see this is a typical IP address, IPV4 address 192.168.56.1, which means we will be typing IP version 4 address in decimal format, while the computer will still have to convert it to binary within itself. So how is computer converting the decimal to binary? That is what we want to look at now. So we are going to make use of what happens inside this octet. For instance, in each octet we have what is called radius and exponents, just like what I am pointing at here, radius and exponents. What are the radius? Radius are the following: 2, 2, 2, 3, 4, 5, 6, 7, 8. Then this one raised to power 0, this one raised to power 1, this one raised to power 2, this one raised to power 3, this one raised to power 4, this one raised to power 5, raised to power 6, the last one is raised to power 7. You know, in your note, if you are writing this, you can just raise it up directly without putting this caret. Alright. So these are the radius and the exponents. Radius are 2, 2, 2, or 2, while the exponents are 0, 1, 2, 3, 4, 5, 6, 7. So if you have to solve this one in mathematics, what do we get it to be? This one will be what? 128. This one 64, 32, 16, 8, 4, 2, 1. Because anything raised to power 1 is, anything raised to power 0 in mathematics is 1. Okay? So now, we refer to these numbers as octets bit values. We refer to them as octet bit values. Why? Because each of these numbers, yes, represents each bit of the octet bit value. You know, inside each octet we have these 8 decimals. These are decimal numbers, while these ones are what? Binary numbers. So this one represents each bit here. For instance, let's take the first octet here. This is like the first octet, second octet, third octet, and fourth octet. Now inside this first octet we have all these values there. Inside this second octet we have all these values there. Inside this third octet we have all these values. Inside the last one we have all the values as well. Now this 128 represents the first one here. This 64 represents the second binary. This 32 represents the third binary here. 16 represents the fourth one. 8 represents the fifth one. This one represents the next one. This represents this one. And this one represents the last one in that octet. That is why this one will refer to them as what? Octet bit values. Octet bit values. Okay. So that is how they are. Inside the second octet too, they are like that. This first one is 128. This second one is 64. The third one is 32. The fourth one is 16, and on and until you get to this place. Now, when you add up all these numbers together, it is equal to 255. If you add 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, it is equal to 255. And what is the implication of that? It means inside each octet here, inside this octet, we can have number in decimal from 0 to 255. Let me show you a typical example of what that is. For instance, the last time I showed you a typical IP address, where we are seeing this one, 192.168.56.1, right? 192, that's the value of one octet. 168, that's the value of another octet. 56, that's the value of another octet. Dot 1, that is another value for one or another octet. Now, you will be writing your IP address in decimal, but computer will have to do what? Convert it to binary. And remember I said, if all these values are the ones that represent this, right? Meaning that inside each octet, just like this place, here, you can have number. Instead of this one that is 192, right? You can have number from 0 to 255 there. This place the same thing. This place the same thing. This place the same thing. You can have number from 0 to 255 there. So now, but instead of us to have maybe 255 or 00, we have 192. What is the implication of that? Now, remember, computer, the binary bits we are talking about is between 0 and 1, right? If everything is 111 all true, that means all the bits are on. And they are what? It is 125. If you have 111 all true like this, right? That means all the bits are on. Then you have the number that is called 255. But if you don't have number like 192 as we have here, what's the implication? That means some bits are zeros, they are off. Some bits, they are zeros, right? And that means they are off. That is something the thing supposed to use like 255, right? It's just like, let me use this street light as an example. Let's say the street light here, if they turn on everything, that means everything is full, right? Yes. But let's say they not turn on, some are not coming up. That means those ones are what? They are off. That same thing happens here. When you assign a value to an octet, it depends on the value that determines the number of bits that is on and the ones that are also what? Off. Let's now check. That is why we need to know binary conversion. I know when we were in school, probably maybe in primary or secondary, we were using one method to convert binary numbers. But here we are going to use an advanced method that even seems to be better than that one we used to. How do we do that? We are going to make use of these octet bit values. For instance, if we are to convert 192.168.56.1 to binary, we will write this one to our computer, 192.168.56.1, right? But the computer will convert it to binary on its own. How will the computer convert this? Let's start with 192. 192 for instance. The first thing you will look at is this. 192, can 128 go in 192? Yes. That means the bit of 128 is on. We turn it on. We now remove the 128 from 192. What will it remain? 64. That means the remaining 64 set off this one set off that 64, right? So that means the bit of 64 is also what? On. We don't have anything left, right? That means others are off. 3, 4, 5, 6, 7, 8. That is the binary for 192. That is the binary for 192. Let's do another one because we are going to do a classwork on it. Let us look at 168. If you have 168 and you want to convert it to binary, you first of all check, can 128 go in 168? Yes. That means the bit of 168 the bit of 128 is on. Turn it on. By the time you remove 128 from 168, what will it remain? 40. It will remain 40. So 64 cannot go in that 40. That means the bit of 64 is off. But 32 can go, right? The bit of 32 is on. Then remove 32, it remains what? 8. The next one is 16. 16 cannot go in that 8. So 16 is 0. then 80 is 1. And that's the end of that, right? Meaning that others are 0. That is the binary for 168. Let us look at 56. 56, 128 cannot go 0, 64 cannot go 0, but 32 can go in 56. That means the bit of 32 is on. Then what remains? 14, right? Then that means 16 cannot go, right? But 8 can go in that 14. 8 can go, 4 can go in 14. So what is remain? Remains 2. So 2 can go, then 1 can, no, there's nothing left for 1, right? Is this one correct? I lost. This is 32, right? This is 8. 32 plus 8, 40. Am I correct? No. Yes.
24, not 14.
It should remain for 24, not 14. Someone who said that? You were the one that made that mistake. Okay. 32 is on, 16 will be on too. So now 16 and 32 will give you what? What is remaining after you remove 32 and 16? Please make use of calculator. This is not jam class. It remains 8. Are you sure?
Yes, 34.
This is what we are doing now. 56. Remove 32, remove 16. What will it remain? 16 again.
It's 8. 24 minus 8.
Okay, 24. I thought you said 32.
Okay, this one gives us what? Okay, by the time you remove 32 from this one, it remains what? 24. Remove 16 from 24. It remains 8. So 8 2 is 1. That one is okay now, right? Others are now 0. That is the binary for 56. But if it is 1 for instance, how will 1 be? That is 0 0 0 0 0 0. It's not 1. That is the binary. That is how computer will convert our decimal to binary. Is it clear?